A spherical balloon is being inflated at the rate of 450 cubic centimeters per second. How fast is the radius of the balloon increasing when the radius is 5 centimeters? Let us say this is the spherical balloon. Let us represent the radius of the spherical balloon by r. As the spherical balloon is being inflated, it becomes bigger and its volume increases. The rate of increase of the volume with respect to time, or the derivative of v, where v means volume, with respect to t, where t means time, is 450 cubic centimeters per second. So, dv over dt is equal to 450 cubic centimeters per second. We are going to find out how fast is the radius of the balloon increasing when the radius is 5 centimeters. We are going to write an equation related to the variables. The equation related to the variables is the formula for finding the volume of a sphere. And this formula is V is equal to 4 over 3 pi r cubed. Next, we are going to differentiate both sides of this formula. So we are going to find the derivative of the left side and the derivative of the right side of the formula. So dv over dt is equal to 4 over 3 pi times 3r squared dr over dt. We can cancel 3 with 3 in the denominator. So we have now dv over dt is equal to 4 pi r squared dr over dt. Next, we are going to substitute. We are going to substitute 450 cubic centimeters per second for dv over dt and 5 centimeters for r. So we have now 450 cubic centimeters per second is equal to 4 pi times 5 centimeters squared dr over dt. We have now 450 cubic centimeters per second is equal to 100 pi square centimeters dr over dt. To solve for dr over dt, we divide both sides of the equation by 100 pi square centimeters. So we have now 450 cubic centimeters per second divided by 100 pi square centimeters is equal to dr over dt. So dr over dt is equal to 1.43 centimeters per second to the nearest 2 decimal places. This is how fast the radius of the balloon is increasing when the radius is 5 centimeters.